Hi, I'm Anaí Muñoz.
With an accent.
Nikki.
Cassandra, I was part of the audience.
Dylan.
Yay!
The objective
45
for today's
degrees
lesson will be the unit circle.
class knows the endpoint for the first one. Dylan.
Square root 2 over 2.
Uh-huh.
It's for the x. And then the y is going to be the same thing.
Oh.
Hashtag basic.
And Dylan, can you explain why it's positive?
Why it's positive is because it's in the first quadrant. Hi, excuse me, I'm trying to teach. Or explain. Thank you.
There's a reason why
It's
we're
in the
talking.
first quadrant. In the first quadrant, it's both positive for the x and y axis.
So do you know the endpoint for the second one?
Radical 2 over 2, and then radical 2 over 2.
So before we start the class, we just want to go over the prerequisites for our course. So to learn our trig, you must know this unit circle. So the unit circle, we put lines indicating 30 degrees, 60 degrees, 45 degrees, all over the circle. And each of these points have an endpoint that you should memorize. Okay, for 30 degrees.
Now take a minute and spend 10 minutes memorizing this.
Yes, spend 10 minutes memorizing this circle.
Learning.
Yeah,
You would want to learn it.
Learning is memorizing, basically.
Yeah.
No, it's not.
So basically, you're learning means you memorized it.
Okay, so basically, rad 3 over 2, comma 1/2 is the 30-degree endpoint. And basically, it's just the same thing for every 30-degree angle, but the positive or negative sign varies based on where you are in the quadrants. For the 45 degrees, it's root 2 over 2, root 2 over 2, and that is the same thing that goes on all around the circle and just varies with the positive or negative. And then 60 degrees is 1/2, comma, rad 3 over 2, and you can see that it's the same thing all around the circle.
So the first lesson today is going to be finding the exact values of cosine, sine, and tangent. So let's start with a practice problem.
Okay, sine of 45.
Degrees, right? Okay, class, how would we solve this?
Okay.
What's the one most important thing that we need, that we use throughout the whole trigonometry?
The unit circle.
Perfect!
Beautiful.
Okay, and where's the 45 degrees at?
First quadrant.
Perfect. Okay, what are the endpoints?
Root 2 over 2, root 2 over 2.
Perfect. Okay, and is sine your y or your x?
It's the y.
Y.
It's the y. Okay, so you know there's a y. So what would be the exact value of sine 45?
Root 2 over 2.
Woo!
Numbers.
Woo.
Yay! Did it. Okay, let's move on to the second.
Teacher, how do you do cosine of 150? Oh.
Wait, never mind, don't do that. Okay,
How do you do cosine of 150 degrees?
We're
Wait, should I give you degrees or should I give you radians?
We're gonna do cosine of
Okay.
3 pi halves.
Yeah.
This time we're doing radians. Okay, where's 3 pi halves at? Located in the
bottom.
It's the bottom.
what bottom? Right here?
That bottom.
The bottom of the circle.
Okay, what are the points for the 3 pi halves?
0, -1.
Yeah.
Is cosine x or y?
X.
X. So what would be the exact value?
0.
0.
As many.
Okay, now let's move on to tangent. This is gonna get a little bit trickier, class.
Oh no, I don't think I'm ready for this.
Tangent of 60. Never mind.
I don't think I'm ready for this jelly. What?
Here's a point, right?
Yeah.
Okay, where's tangent 3 pi fourths located at?
It's it is.
Oh,
I'm trying to add it. 135
Before
degrees.
4 pi 4.
135 degrees.
So where are you? How come? Why don't you come up here and draw it?
Wait, let me draw it.
Okay.
No, Nikki,
Okay.
you do it.
Okay, class. Okay, since we have pi over here, we can say, well then 3 pi fourths is 1 pi fourth before that. Pi
That looks accurate.
4. Okay, so tangent is the y over x. So it's basically sine over cosine. So what is the coordinates here? It is
Negative square root of 2 over 2 and square root of 2 over 2.
yes.
So what would be your answer?
Negative 1.
Yay!
-1.
Very good job. Let me just write it out so you guys won't get confused. So it's the y over the x. Okay, and then it's right equal 2 over 2, and this flips, times 2 over right equal 2.
Then you cross
So it's
cancel.
negative. Gives you a big fat negative 1. There you go. So that concludes our lessons for finding the exact values of cosine, sine, and tangent. Solving right triangles.
How do you know if it's a right triangle though?
Because it's pointing right and it has a 90 degrees. It's 90 degrees. Okay.
I don't have one.
It's okay, I can make
Wait,
some.
now I'm gonna draw a triangle.
That's like 4.
Fantastic Four.
Oh shit.
It looks like a Dorito. Yes, we have an eraser.
Stop. Don't use this marker.
This is how you draw.
Two blue. Wow.
You didn't finish it.
You went too far.
Teamwork. Okay, guys, so we're gonna solve the right triangle.
You sound very excited.
Let's see if this works. X. 3. Hopefully that works. Okay,
Oh, yeah.
so for solving a right triangle, we're gonna try to solve all areas, which is A, B, C,
Little A.
A. Oh no, A's over here.
Yeah.
B and little c.
Yeah, when I erase the X.
Oh no, because we're solving. Oh,
Basically.
true. Okay,
Yay.
so you're gonna
So
solve
I
the
have two
right
topics
triangle.
for this.
Shh.
Love it?
Do you want more topics?
Okay, now.
Okay. And now what you do, you
So what-
use the trigonometry identities. Okay, so let's start with the information that we have. First, what I do is I label the triangle. So this is hypotenuse, and since this one's given to us, this would be opposite, and this would be adjacent. Okay, so far we have enough information to solve for A. So let's go ahead and use tangent, because it's opposite over adjacent, so TOA. So tangent 30 equals A over 3. Do you guys understand this?
Yeah.
Okay, now what we do is A equals 3 tangent 30. Do you guys understand this?
Yeah.
Okay, can someone tell me what A is equal to? What little a is equal to?
Opposite over freaking over adjacent.
Yeah, but what is it? If you put it in a calculator, what is it equal to?
Oh, that'll be easy. You just put, I don't know. Oh, sure there.
Give me a calculator.
Cassandra got it. You go, Cassandra.
Square root of 3
square root of 3.
Mm-hmm.
So now that's what A equals. Square root of 3. Okay, now we have another one. Okay, we can go ahead and erase these so we won't get confused. Okay, so now we still need to solve for little c and big C.
Okay.
But since we have two sides, we could go ahead and use what identity?
Pythagorean theorem.
How do you use the Pythagorean theorem?
So Pythagorean theorem is a squared plus b squared equals c squared. And this is a, b, and c. So it's squared plus b squared equals c squared. So now it's 3 plus 9 equals c squared. 11 equals c squared. Cancel the squared. C equals
Wait, teacher,
radical 11.
I think you added wrong.
Sorry, class, mistake. It's 2 radical 3. So now we have our C. So it's 2 radical 3. 2 radical 3. Do you guys understand this?
Yeah.
Yeah? No blank stares? Okay. Okay, now all we need is to solve for big C.
Wait, what's big B?
Oh yeah, and big B. Okay, so now since we have all the sides, we could use our what identities?
Wait, do you already know what C is?
Yeah.
We know what this one is, but what can we use to solve for the inside angles?
Oh, we can deduce it because the inside of the triangle is 180 degrees. So
Yeah,
90 plus
60.
30 is 120. So you know that B is 60.
Perfect.
B.
So B is equal to, you know that it's equal to 180. So it's 90 plus 30 plus B. So it's 120 plus B equals 180. So B equals 60 degrees. And this is a special right triangle, the 30, 60, 90 degrees.
Mm-hmm.
That's another way. There's many ways of solving this. Like we could have used sine, cosine, and tangent also to solve this, but that's hard because we already have the 30 and the 90, which we know is 60.
But that's hard.
It's not hard, it's just more work. But you see, we learned this.
Yeah.
We didn't memorize it. We derived it. Okay, class. It was really nice. Hopefully,
It's really nice. It's
Come
like
back next time.
Ready?
Yeah.
a little bit of circus here.
Woo!
Ah, I missed it. Look how you can.
And what do we have on the bottom, class?
3 by 4.
3 by 4.
No.
Good try.
2 pi thirds.
No.
No.
3 pi over 2.
Yes.
Sure.
You walk like. More like this. More like this. Like. Pretty short.
Oh my god, it's a score on my final. Could it be solving left triangles?
No.